Okay, class. I don't know what in the world I was thinking today in class, but when we got done with our Chapter 1 review, which was valid, we never did the Chapter 2 review. And so I just went from Chapter 1 to Chapter 3. So everything I told you about Chapter 1 is valid for the test. The problems I told you about to work from Chapter 1 are valid for the test. But now we need to take a look at the Chapter 3, or the Chapter 2 problems that we just didn't go over. So we'll take a look at some of those here. So here are some of the things that we were working on from Chapter 2. And from Section 1, you need to know how to find distance and midpoint, which is basically going to boil down to knowing these two formulas. Here's the distance formula, square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And the midpoint is simply x1 plus x2 over 2 and y1 plus y2 over 2. So if we applied the distance formula on this problem, I usually just label the points in order, x1, y1, and x2, y2. Then we would have had 2 minus negative 4 squared plus negative 5 minus 3 squared. 2 minus negative 4 is the same thing as 2 plus positive 4, that's 6. And 6 squared is 36. Negative 5 minus 3 is negative 8. Negative 8 squared is 64. So really I have the square root of 100, which is 10. Okay, and then for the midpoint, applying this formula now, x1 plus x2 would be negative 4 plus 2 over 2. And y1 plus y2 would be 3 plus negative 5. Having trouble getting my pen to write. Over 2. Oh, I know why. Here. And of course, both of those are negative 2 over 2, which is negative 1 and negative 1. So make sure you know how to find distance and midpoint. In Chapter 2, Section 2, we discussed equations of circles. And so you're going to need to know the center radius form of the equation of a circle, which looks like that. So if I gave you the center and the radius and asked you for the equation, all you'd have to do is plug into the formula. Here my h is 0 and my k is negative 3. So x minus 0 would be the same thing as just x squared, plus y minus negative 3 would be the same thing as y plus 3 squared is equal to r squared, or 4 squared, or 16. And that's about it from Section 2. Section 3 was all about functions. Remember, if you have a graph that passes the vertical line test, like this one does, no matter where I draw a vertical line, the most it ever crosses once, then it is a function. And if you have a graph that does not pass the vertical line test, like this one, there's a line that crosses more than once, then it's not a function. So you'll need to know how to apply the vertical line test. For function notation, you probably remember that it's just a matter of substituting the number in for x. So f of 3 is going to be 5 times 3 squared plus 3 times 3 minus 4. And if you crunch the numbers on that, you're going to get 50. So function notation is not too bad. And then we had problems where we found the domain and the range from a graph, and then we also found intervals increasing, decreasing, or constant. So let's say I had a graph that looked like this. And let's say this is the point -1, -2. And let's say that's the point 1. Okay. For the domain, remember we look at all the x values, so we're looking at the x-axis. And notice, no matter what point I pick here on the x-axis, there's going to be graph associated with it somewhere. So the domain is -infinity to infinity. For the range, I don't look at the x-axis, I look at the y-axis. So I'm looking down here on that axis. And we see we don't have any y values represented until I get to this y value of -2. And then all these y values up here would be represented because of that arrow. So the range would go from -2 to infinity. Okay. Increasing, when we look for intervals increasing, decreasing, and constant, we're looking for intervals of the domain. So we're looking for x values. And increasing means I'm moving up hills. I move from the left to the right. So this is the only part of the graph right here in blue that is increasing, and that runs from an x value of -1 up to an x value of +1. Decreasing means where is the graph going downhill? Well, obviously that's happening over here in red. So it's happening forever until I get to an x value of -1. So it goes from -infinity to -1. And then constant then is where we flatline, which is all this, which starts at an x value of 1 and goes to infinity. Alright, moving along here. Chapter 2, Section 4. Graph and find the slope and the y-intercept. We know that when the equation is solved for y and f of x means y, that we're in slope-intercept form, and the slope is the number multiplied by the x, in this case 2, or 2 over 1, and the y-intercept is the constant, so in this case 5. So for the graph, I'd go up 5 on the y-axis, and I would rise 2 as I run 1. So up 2, right 1, boom. So there's my line. That should be very familiar. In section 5, we were writing equations of lines, and I kept stressing over and over that if it says these 6 words, find the equation of a line, that we want to go y equals mx plus b, and we want to find the m first and the b second. So in this problem, to find the m, we'll use the slope formula. If I let 3 be my y2, then y2 minus y1 would be 3 minus -2 over x2 minus x1 would be 6 minus 4. So what we got there? 5 halves. So my equation is going to be y is equal to 5 halves x. And I need to find the b. And to find the b, we can use either of our 2 points. It doesn't matter. Any one will work. I think I'll use 3, 6. So 3 will equal 5/2 times 6 plus b. So 3 will equal 5/2 times 6 is 15 plus b. So b is going to equal -12. And our line is y equals 5/2 x minus 12. If it says to put the answer in slope-intercept form, we're finished. If it says to put the answer in standard form, then we have to make sure the x and the y are on the same side. Usually we'll make the a positive, and we'll clear out the fractions. Alright, what I want you to take from chapter 6 is how to find function values from piecewise defined functions. Here, f of x is 3x minus 2, but that's only for x values less than 1. If x is greater than or equal to 1, then we're going to use 4x plus 6. If I ask you for f of 0, my x is less than 1, so I'd put it into 3x minus 2. So that'd be 3 times 0 minus 2, or -2. If I ask you for f of 3, that's greater than or equal to 1, so now we're going to use 4x plus 6, so we take 4 times 3 plus 6, which is 18. So make sure you know how to substitute into a piecewise defined function. Okay, now let's go to section 7. Okay, this is where we were doing all the transformations on the graphs. So on a problem like this, I'm going to ask you not only for the graph, for the actual answer, but also what transformations did you use to get the answer. So in other words, if we think about this problem, the parent graph is the squaring graph. Looks like that. And remember, we do the constant last, and if there's a negative on the x, we do that next to last. But here there's not a negative on the x. So we're just going to work it from our x out. So the first thing I'm going to do is plus 2. And since that's inside the parentheses, that's a horizontal shift opposite the sign. So we'd actually go left 2. So if I go left 2, that's going to put me over here. Then if I consider this negative out in front of the whole thing, that's a reflection about the x-axis. Remember, if the negative's on the x itself, it's a reflection in the y-axis, but that's not what we have here. So that's going to put me here now with squigglies. And then finally I can handle the plus 3, which is going to put us up 3. So I want to see this. I want to see what you did to get your answer, which is left 2, reflection about x-axis, and up 3, which is going to give you a graph that ends up looking like that. And remember, we had those 6 parent graphs that you need to know. The squaring graph, the cubing graph, the cube root graph, square root graph. We had absolute value of x, and then we had the identity graph. Okay, as far as symmetry is concerned, remember to check for x-axis symmetry. We put x negative y into the function and see if it held true. If I do that here, negative y would equal x squared plus 3x minus 2. Solving for y gives me y equal to negative x squared minus 3x plus 2, which is not consistent with what I started with. So we do not have x-axis symmetry. No, that says no x-axis. It's just very ugly. Okay. To check for y-axis symmetry, we put negative x in for x and y in for y. So that'd give me y equal to negative x squared plus 3 times negative x minus 2, which is x squared minus 3x minus 2, which is also not consistent with what we started with. So we have no y-axis symmetry. And then for origin symmetry, we put negative x in for x and negative y in for y. So it'd give me negative y equal to negative x squared plus 3 times negative 2 minus 2, or negative y would equal x squared. What did I write there a moment ago? It's supposed to say negative x right there. It's an x. So minus 3x minus 2. So y would equal x squared plus 3x plus 2, which also is not consistent with what we started with. So here's a graph that doesn't have any of the 3 types of symmetry: x-axis, y-axis, or origin symmetry. So none of those. Okay, and then finally in section 8, what you need to know for your test is how to do composition of functions. If I'm asking for f circle g, remember we'll start with the first function. F of x has 3 times something plus 6. And then wherever the something is, that's where we put g. So 2x minus 2. And then we'll simplify that. So here we'd have 6x minus 6 plus 6, or simply 6x. Okay, so let's make sure that we're golden on the review problems. The problems I told you to do from chapter 1 today in class, you need to do those for the test. The problems I told you to do on Wednesday from chapter 2 for the review, you need to do those to be ready for the test. And then I told you to make sure you know how to do synthetic division from chapter 3. So, I hope that helps. Again, sorry for the confusion. And I hope you do well on the test next week. Just to make sure we're on the same page, these are the problems I gave you out of chapter 2. These are the problems I gave you out of chapter 1.